Hello everyone. Today I would like to discuss certain general examples related to Newton's laws. So let us understand with a short video. So observe this video very carefully. So now he is an long jump runner. So he is running and he made jump and he jumped at 9 meters. So play it again. So he is running fast. Now he has increased his velocity. Now he had jumped and it's Olympic world record. It's jump up to 9 meters. So he is in happy, he is running. So let us understand our physics at here. Now, so his person is having mass. So if I take this mass equal to small m, and initially he is at rest. Now he is not moving. So he is not moving, so its initial velocity u equal to 0. Therefore initial momentum what the momentum we can write? Momentum equal to product of mass into velocity, mass times velocity. So if you can write that as momentum, so I will write now initial momentum. Momentum initial equal to, here the mass m itself, we'll take the mass m itself, and velocity equal to 0. Therefore initial momentum of this earth rate equal to 0. Now because he is starting, so till now he did not start, now he started. Now he is starting and he is running fast, and here he is in the air. So but I want, this is the initial case. Now if I play at here, I like to catch at a right situation. Now at here you can observe, ask a question. That question is, why did he run? So I can take light color, it can be visible. That the question is, why did he run? Ask a question, why did he run? So this is something like silly question. What is it necessary to run? So your answer will be to jump. And to do a good jump means it's a long jump. To do long jump, he need force. He need force. So here, how did he get the force? Did anybody push him like that? No. No external force applied. So there is no another external force. Somebody do not come and push him from backward. So they did not do. So he run certain distance and he run very fast, accelerated motion. Slowly he started, then after he pick up speed more, and that motion we call as accelerated motion. Now in that accelerated motion, if you can observe, so he picked up a very good speed. So he picked up very good speed, and now he is starting and running fast. Now at here, so to cover this long distance, so his aim is an Olympic medal. Olympic medal do not come easily, so he need to cover long distance. So he covered up to 9 meters. Okay, to cover 9 meters, so he made a jump at here. Now if you take this as a baseline, and now at here if I calculate this person, the athlete momentum at here. Now if I take his mass, so mass do not change, mass equal to m only, but velocity has changed. So at here if I take final velocity equal to v. Now if I can calculate the final momentum final equal to product of mass into velocity. So here we got two momentums. One is initial momentum. So at the initial case, so this is his initial momentum, which is equal to 0, and after taking certain run at here, and he made a jump, and at here he had certain momentum. Now if I write the change in momentum, so the change in momentum, what the change in momentum formula you can write? The change in momentum is nothing but initial momentum minus final momentum, or we can write final minus initial. So if I write change in momentum, so therefore change in momentum, so how can I write the change in momentum? Momentum final minus momentum initial. So momentum final, here we got the value m into v, and initial momentum our value goes to 0. So he had the momentum, change in momentum value equal to m into v. So this is the way to calculate change in momentum according to Newton's second law. What the Newton's second law says? Change in momentum is equal to applied force. Yeah, so that's the reason why he run. So he needs certain force to jump. We know that what is the effect of running and coming to take jump, or simply standing and taking jump. So if you run and take jump, so we can cover long distance. So if we usually practice, so we can run, and that run also very fast. We have to run very fast, then only we can gain velocity. So that creates momentum. And if you can calculate initial momentum and final momentum, so how much the value is present, that creates a force to jump. So here the Newton's second law works at here. So the Newton's second law says that the change in momentum is equal to applied force. Now I hope you got why athletics should run before to take jump, because they need force to take long jump. How did they get the force? By running. So that is, we can say, in terms of Newton's second law. So finally the Newton's second law says that the change in momentum is equal to applied force applied. So finally, if you can watch this one more time, so this is athlete, it's the initial mass and initial velocity. So initial velocity 0, now he started and he running very fast and he had jump, so he covered 9 meters. So this is the Olympic world record. So let us understand much about the change in momentum. So here if I can close this, so if you can take the statement of Newton's second law, the rate of change of momentum of an object is proportional to the applied force in the direction of force. So this is the Newton's second law, and we already derived the Newton's second law. So consider a mass small m with initial velocity u and accelerated to a final velocity v. So first we need to calculate initial momentum initial, mass into velocity, and final momentum P2, mass times final velocity V at here. Now change in momentum equal to P2 minus P1, we need to subtract. So we can get mv minus mu. After that we need to calculate the rate of change of momentum. If you can calculate the rate of change of momentum, finally we get an expression F equal to ma. So if we can do that as a simple manner, let us see this game baseball. So to hit the ball, what the batsman used to do? So observe the batsman very carefully. So he's hitting ball very hard. So the ball is going miles away. So how he is getting force? That's we can understand. So he is applying force with the help of bat. See how the great shot it was. So how we can calculate that force? Or how we can measure that force? So to measure that force, let me take one slow motion video. Suppose if I play this video, so understand the batsman hitting the ball very carefully. So now it is playing very slow motion to make you understand. Now still did he hit? No, he do not hit. Now ball do not reach. Now the movement of the bat you can observe. So now the ball went away. Now I would like to calculate the force. So for that, what shall I do? Now I need to calculate the two ways. So here we will calculate that force. So here we can calculate the first, we will calculate the change in momentum. So this baseball bat having mass. So its mass equal to m. And still bat is at rest. So initial velocity of the bat u equal to 0. Now in this case momentum initial, product of mass into velocity, so initial momentum equal to 0. Now the initial momentum equal to 0, till now bat is not moving. Now the bat is slowly moving. Now because the batsman is applying force. Now he is swinging the bat. Now he applied force. Now at here the bat is applying force on the ball. Now here the bat mass equal to m, but the bat velocity has changed. Its velocity equal to v. Now how much force is applied on this ball? So to calculate how much force is applied on this ball, so what we need to calculate? We need to figure it out what is change in momentum. Now in this case the final momentum final equal to mass times velocity. If I take numbers in the initial case, let bat mass of bat equal to, let us take as 3 kg, and velocity, initial velocity equal to 0. So initial momentum equal to 0. So that is in the initial case. When applied force in this case, so mass of the bat is same, mass of the bat m equal to 3 kg. Now if I take the velocity, final velocity equal to, let it take as in a 40 kilometers per hour. Now if you can calculate the final momentum final, product of mass and the velocity equal to 40, so momentum final equal to, so 120 kilometers per hour, kg kilometers per hour. Now we can calculate the change in momentum. Therefore change in momentum, which equal to momentum final minus momentum initial. So final momentum, we got the value 120 kg kilometer per hour and initial goes to 0. So he applied a force 120 kg kilometer per hour is the change in momentum. So that much amount of force is acting on the baseball. So that's why the baseball is landing far distance. So that is the amount of the force is applied. So that's the way to calculate. Or we can calculate this in the different manner also. Suppose if we know the force, suppose if I know the force, if the force applied by the batsman hitter is F, and that force applied in time interval of small t. Now if you can multiply these two things, the product of force and time, so this is we call as impulse. So the force acting in a given time interval. So let us understand that with a different example. Let us take this case. Now this karate man having black belt in karate, he know the technique, and just observe how he can able to break that blocks, cement blocks. So what is the technique? So with the bare hand, see how he did it. So it's so wonderful. So I want to see that again. So he did not apply more force, he did not use any hammer, just hand, and he applied on it, and the force he applied in very short time. See how fast he did it. So he applied force he applied, and time t is very short. So that's the reason that is the impact of the impulsive force. So the force times multiplies by the time he applied very short, so the time interval is less, so the change in momentum is more. So that's the reason, even though he applied very small amount of the force, so he can able to successfully break the blocks. Let me take one more. So this is also, let us watch. Now this times the blocks are doubly layered. See, they are the thicker. Now he is getting his strength and taking position exactly he wants to apply, and you can just notice how fast he will apply the force. So to break that blocks, here the technique is fastness. To break the blocks, here the technique is fastness. How it is? Because our formula, force times multiply time. If force is applied and the time interval t, so the impulse force is increases. So please don't try this without knowing technique, because it will get hurt. So if you do not know the technique, we should not apply it. And not only that, according to Newton's third law, how much force we are applying on the blocks also applying same amount of force on our hands in reverse. So if we do not know that technique, so our hands get break. So don't follow this technique until unless if we become masters in that. So this is only for explanation purpose. Don't try it at all. So let me explain this impulsive force with a very general example. So this is an example. We are throwing eggs. We are throwing egg in one of the solid wall and in another cloth wall. Now when the egg is thrown to a solid wall, so here you can take this is a wall which is solid. Now you can see it's broken. It's a broken egg because the impact of force and time. What is the force we throw and what is the time? And when we do the same thing in the different, now here you can see here the wall is not solid. So this is not solid wall, it's a cloth, just as a cloth. Now if you can observe, the egg it's saved. So what is the reason? So in the solid wall, and force is more and time is less. Force is more and time is less. See, here you can see the size of the letters. So that's the reason it's broken. So in another words, I can say impulse force is more. So in this case, impulse force is more. So this is the same reason how the karate person he able to break the blocks. The force applied in short interval of time, that leads to more impulsive force. Suppose if we take what is the effect in the another case. So now in the cloth, now here we can see the impact of time. So the impact of time is more. So because of that, force effect becomes less. So this is the very useful example. Usually when we jump, what should we do? We should fold our legs, because when we jump we are applying force on the surface. According to Newton's third law, the surface also will apply force on us. So if that force is more, there is a possibility to get ankle break or ankle dislocate or bone fracture. Those things happens. That is due to because of impulsive force. To save our legs, what we do? We should increase the time. How we increase the time? So we increase the time by folding our legs. So that is one of the jumping technique. So I can show that one also. To do safe jump, so this is the landing position of a jumper. So he is jumping and he took the jump and he applied force, and while he is landing, so he is going to land. So this is playing slow motion. So here you observe his legs motion. Now after that we need to fold our legs. So while folding our legs, what happens at here? So the jumper is applied force on the surface. So this is the force applied by the jumper. So according to Newton's third law, the surface also applies force on the legs in the same amount but in the opposite direction. So the force applied by the surface or land, which equal to minus of force applied by the jumper. So if we do not fold the legs, so what happens? That force is passes through our foot to our leg. So we talked about force and impulse. The product of force time impulse known as, the product of force and time is known as impulse. So if to save our legs, we need to increase time. So how we can increase the time? Here time is what? The effect of force on legs. So to increase the time, what we do? We need to fold legs, or in the better, we need to just roll on the surface. Usually when parkers used to do, so they used to roll. So that saves our leg. So this is also an impact of what we can call that is the impulse force. Or the same technique if we can apply while catching. Suppose if you are catching a ball, so cricketers used to catch the ball. So when the ball is having momentum, mass into velocity, if you are catching the ball just like that, so our hands get hurt because the ball is coming to rest very fast. So the effect of change in momentum. So if we can pull our hands down like this, so we are increasing the time of contact. So that time of contact decreases the effect of force. So our hands will be safe. So to reduce the impulse force, so what we need to do? We need to lower our hands while catching. While catching, we need to lower our hands, and while jumping, we need to fold our legs. Certain techniques we need to follow, otherwise legs get hurt. So this is all about change in momentum and impulse. Just apply whatever we learn, the understanding about impulse and change in momentum. So just watch this video. A toddler, a small kid. So he's learning karate and he's trying to break that one small plate. And see how he is struggling. The coach is training him how to break and he is applying force. And his force is not enough, not sufficient, and he is trying a lot, and he is doing as his best, and that force is not at all sufficient. And if he know the technique, so what the technique? He need to apply force in short time. And yeah, now he is training well. Now he can able to do. So yeah, so he can able to break the plate. How? Even though he is small, his force is less. To increase the impulse force, so the time, it is the matters. So this is all about change in momentum and impulse.